ready for your presentation.
Okay. Kia ora. Of course, I'm Michaela Maho. So in New Zealand, we've moved to using Te Reo in part of our speaking. So I've got my little background here. So if I go in there. That's me in the bottom corner over there as a wild man, because I'm a New Zealander, and so of course I was an extra in Lord of the Rings. But I've been working in neural networks for nearly 30 years. I started my PhD in 96, so that's quite a long time ago. And I've been teaching AI courses and mostly game development since 2004. And I still have a 20% position in NTNU. I'm full-time at Wellington, and I have an adjunct position at the Central Queensland University. So kind of bouncing around all over the place. Traditional programming has been, so I like using analogies. So for me, traditional programming has been a bit like being a classically trained musician. The idea is that, when I started to learn to program, I had to learn to read sheet music, I had to play all the instruments, and when we're like doing crazy things and you're actually like soldering things, it's like you're making the instrument and then learning how to play it, and then learning how to make bespoke songs and concertos, and so there's kind of this depth of understanding how each of the components fit together, and so this deep, rich history of my learning to program is kind of analogous to this sort of a deep understanding of a musician. Now, when we're programming, what's happening is that instead of just forcing out music to fit with what's in your head, when you play a violin, you have to hear the notes in your head, but you shift them to what can be done with the violin. When we're programming, a lot of what you're doing isn't about getting the code to do exactly what you want it to do. It is about bending your mental model. It's about shaping the way you think about the problems to the instrument you're using. So when we think of a procedural programming language, that might be like strings, and then suddenly you go functional, and now you're all percussion. And you've got a different perspective. Some things are easier, some things are harder. But a lot of that job is shifting that mental model. And so for me, like, over half of the debugging process isn't just about me forcing the code to fit what I was thinking in my mental model. Half of it is me bending my mental model until I understand what the code is actually doing, and I understand the true problem I have, and then changing code. So you kind of have this flow back and forth between the code you're working on and your mental model of the problem. Unfortunately, or fortunately, we all live inside human brains, and our problem is that we learn through emotional significance. So when I'm using this complex debugging process, what I'm actually doing is I'm to some extent sometimes very frustrated with my code. Some of you might have been frustrated with code, and that frustration is registered in your brain and becomes part of the why should I remember and learn this? Because overnight, when your brain turns your daily activities into your long-term memory, it ranks what was important by its emotional significance. So not only are we learning code by practicing it, we're also learning code because we get frustrated and because we feel joy when you solve those bugs, right? So that emotional salience is the thing that like ranks how important memories are to store long term. Now, and that makes it kind of really kind of, well, okay, if I'm going to learn to code, I don't just need to be coding, I need to care about what I'm coding. Because if I don't care, my brain's not going to value it, and I won't store those memories. Right? So we've got this this complex layering of bending my mind into the code, making my emotions link to being successful at doing that, and then sleeping overnight to store that into long-term memory. Now, interestingly, I asked for that diagram I just asked for, just as a kind of prompts and tools matter. If you ask ChatGPT or Gemini to create a diagram showing a loop back and forth of changing code and aligning the understanding, it drew me this diagram, which you might notice that some of the words in there aren't quite what they should be. Now, yes, certainly OpenAI and ChatGPT are getting better at drawing diagrams, but what it's trying to do here is create pixel by pixel an image. Whereas if you tell it to use a tool to create an SVG, that is then a language of creating a diagram, and then it produces this kind of diagram because it knows that, oh, I will write code, and inside that code, those words will exist. And so it makes it much easier for it to do words. It also means I can edit it because it's a text-based diagram. So there are these subtle shifts in the way you think about using AI, from just saying, hey, make an image, to, I know you're good at language. I'll make you use that feature to generate images for me, and I'll do them as text-based diagrams. Now, this kind of thinking about how do I shape my brain into working well with AI is a new skill, right? It's like debugging, but it's about shaping the way you understand what the tool is good at and how you adjust your desires as a programmer and as a developer into working with the AI. So I thought that was a kind of interesting example of me getting diagrams done by AI. Oh, and by the way, all the images are AI generated, as you can imagine. So moving from that classical bending my brain, thinking about how I shift my brain to work with code, from about the sort of even maybe in the 2000s, but certainly from the 2010s, my feeling is that we moved as programmers away from classical musicians into kind of DJing, right? Where what you did is you just smash APIs together until you create a solution, and then you hand it over as a big bloated API mess with little bits of code that hook the API together, and then you walk away, right? And so for me, this feels more like, you turn up to a gig as a DJ, you grab your whole sample of music, you kind of make things link together, and through that linking, you create entertainment and you engage the audience, and you see what's working and what's not working until you get a good entertaining evening, and then you just dump that session and move on, and you've got a new session. So it's bespoke combinations rather than bespoke code, right? And so this is a kind of quite a different way of thinking about what we should be teaching people, because there's plenty of musicians who call DJs not musicians but performers, right? Because so there's this kind of, some musicians will look down on DJs, saying, well, they're not as talented as I am and they can't read sheet music. And then DJs go, yeah, but we make all the money at the weddings. So it's kind of this discussion of what it is to perform and to create and to entertain. In the programming space, this has become very much of that. How do you solve problems for a company? Well, you smash things together. That, for me, opened up this big debate about, do we teach sheet music? Is that the correct thing to be teaching people? When we look at AI language models, right? So we've now got this we're DJing, right? How have our tools changed? And our tools have changed that we've added these language models. Now, rather than go through and try and deeply understand them, I'm just going to hopefully give a really short summary. But transformers grew up in translation, right? So they actually grew up as part of how do we translate this sentence to this sentence. And they did that initially when Google was doing the transliteration stuff. It was pretty bad. And so to translate well, you have to extract the meaning from the sentence and then express it in another language. And so the transformers got pretty good at extracting the semantic meaning, sort of understanding the language, so that they could then re-express it in another way. So if you're looking at using ChatGPT, its best features are actually when you give it context and then you ask it to translate that concept in abstraction level, right? Or into another language, into a simpler language, into a more complex language, to summarize a large context. These are the things where it's kind of translating, but translating within language levels and those sort of context-rich and content spaces. Just because it was good at doing translation, it also then added the ability to generate text. And that's when we got this generative chat-based AI. And because AIs created good verifiable domains, right? So code is a verifiable domain. What that allows us to do is that, unlike language, where we were limited by the language of humans on the internet, and we've scraped most of it, we've trained the AI on a lot of the internet, and we're kind of running out of internet valid data, because a bunch of it is now over 50% of all the text being added to the internet is AI generated. So it's not really the valid kind of this is how humans interact. It is kind of this is how AIs mimic humans interacting. However, coding spaces have a validation, right? We can, as a domain, we can validate new example data. And that's why the AI coders are becoming much better. Okay, so as we're going on, we've got this language translation, we've got this DJing of smashing stuff together, we've got these programmers which have started adding the LLMs. They initially were just doing translation, then they were able to kind of translate some bullet points I wanted into code. They were able to expand on a comment and add what was going to come next. So we started seeing these co-pilots. Recently, so end of last year, we started adding reasoning, verbal reasoning. So what they found is that although the AIs are not, well, they're doing a little, if you have a look at the deep sea, look at Anthropic's sort of the biology of LLMs paper, you can see it is doing a really short range reasoning, but not long range reasoning in context to generating an output. What they found is that because it's generating a word and then reprocessing, and generating a word and then reprocessing all of that, you can create verbal reasoning, right? So it's able to talk through its model and talk through what it's planning to do by internal talking to itself. And from a compute perspective, basically we've moved from putting all of the training into how do I make the LLM better into test time compute, so that when you ask a question, it starts working through the answers. Now, initially, O1 and O3 kind of hid their reasoning. DeepSeek then made it available, and so ChatGPT went, oops, okay, we'll just make all of our reasoning available, and now all the models use this reasoning available system. So you can now use language to create plans, and then use that as input into the model, so that you can now create these long-term plans. You can create an approach to solving problems. And this is great for improvements for AI programming, because as a programmer, you're not necessarily going to be able to write the entire code from the first line and then just write it, right? Because it's just, you've got to have lots of levels of planning, right? So you're going to plan, I'm going to have the UI system, I'm going to have the event system, I'm going to have the interaction system. So you've, as a physics system, you've got to plan all of these things. So there's lots of hierarchical understanding. And so rather than just an LLM doing straight ahead read through the code, and the AI presentation last week, that the way you scan code is if you're just going straight ahead, that's probably not the best way to create it or to think about it. What AI reasoning is doing is it's able to create those hierarchies and expand parts of code at different times. And it's using the reasoning feature to do that. We then started at the end of last year, beginning of this year. So actually, we had some agentic AI systems, but because the agents didn't have this reasoning mode and they weren't iterating on their logic at inference time, it was kind of very hit and miss. So LangChain was the idea you can create agents, you can wrap them together, but the agents were all a bit silly. And if you let stupid people work together, they create stupid outputs. So it's kind of, they're not great, but they're there. The combination of reasoning and AI agents give you much, much more powerful AI systems. And you then can start asking the AI to do things. And you then provide tools to the AI. So you add tools for doing file creation. It can create scripts and run scripts. You can add the ability to pull and push from GitHub. So you add a bunch of tools. You let the AI be able to pause, call a tool, get feedback from that tool, and then continue with its reasoning. Right? So there's this agent that can pause, process, and continue until it hits the next impediment, get that done by something else, and then continue. So there's this back and forth between the AI that is doing programming and testing tools and file management tools. So this came to a post in February of 2025 where Andre Karpathy coined vibe coding. So yes, that he calls vibe coding. So this talk actually basically comes from that idea of this vibe coding. He's using Cursor Composer, which is now called Cursor Chat, with Sonnet, and that was Sonnet 3.7, and it was again an agent that had some level of reasoning. He also is using Super Whisper, so that is just using the Whisper audio transcription. And so you can just sit there chatting to the chat window, turning it into the accept all, always on, just keep going. At one stage that was called YOLO, you only live once mode, where you just let the agent rip and you just rush through, and your goal as a programmer is no longer to understand the code that's being made. It is to understand the goal, right? That is a radically different way of thinking about this. Basically, you move up to being a product owner, and you're not interested in how they're implementing the goal. You're just defining that goal and trying to push them through. It's become a new way of coding. It's a bit like going to a band and saying, "Hey, I want you to play certain music." Right? I'm not sure how you're going to play it, but I want it to be cool and relaxed, and then be a bit more upbeat, and then I want to kind of go into a slow bit, and I want to have some slow dancing later in the evening. So go ahead, make something awesome. Right? Now, that's not what we think of as programming. Right? That's not what a musician thinks of being a musician. Is the person who says what the feeling, the vibes of the night's going to be, and then tells a group of agents, go ahead and make that happen. Part of this thinking comes from an experience with AI, which we didn't necessarily expect, which was that over-specification often resulted in lower performance. So, for example, AlphaGo was trained on all of the human Go tasks, whereas AlphaZero learnt to play Go by itself without seeing human games. right? And by showing it just human games, we kind of over-constrained it. And what we're finding with prompting, sometimes if you give it too much specification, too many kind of goals that it has to work with, it ends up creating less effective code. Because if you just vibe it out and just say, hey, this is the vibe, and let it just keep running and choosing things, it will smash together tools, it will smash together content until it gets this kind of to a solution. Now, that's remarkably unsatisfying as a programmer. I feel that that's tearing at my heart of the no, but you don't know how you got where you're going. You haven't learned anything about the path. You don't know how to do it faster next time. You haven't changed anything inside your head when all you've done is yell at the AI about where your goal is. Right? So I think, although as an experienced programmer, I can use vibe coding to get a product out really fast, and I can go in and see what it's done and kind of tweak it and improve it, I don't think it is the best way for our students to learn what it is to be a programmer. And this goes into that effort and time mode. So for vibe coding, it makes things easier. And what's happened now is we've lost the link between the output the students produce and the effort they have to put into it. And because I've got this mushy thing in my head which requires time and effort for it to change the biology, right? Because it's biological connections. Vibe coding doesn't give me that time and effort that I have to spend, right? So the idea here is that this AI, forcing AI to the goal, is not aligning my understanding with what's being produced. So I need to find a new way of motivating students to saying, yes, debugging is much easier when you've got an amazing vibe coder, right? In fact, what happens with vibe coding is you mostly stop debugging because you just take the bug, you throw it at the AI and go, AI, fix it, and it fixes it. And you can go away and you look out the window, think for a while, think about other things, and just get it to solve the problem. It's really good at writing test cases. So if you want test coverage, fabulous, right? It can look at all your functions. Again, that's a translation task. Translating between code and test cases that test that code, it's kind of translating. And so it's really good at building test cases. But the problem is that I'm not spending any effort and time. I'm not developing an emotional connection with my code, and therefore my brain will not think that any of those activities are relevant or useful when I'm sleeping to encode into long-term memory. So my knowledge of the code and my connection to what I've developed will keep fading. Now I asked AI, hey, draw a diagram of this, and I thought it was I actually only asked it for draw a link between effort and output and say it's a broken link, but then it decided to also do this whole AI machine learning, automation tools, digital leverage, I don't even know what it was meaning by that, and minimal time effort, one-time setups, and massive outputs. So, it expanded on my original idea to add all of this additional content and, content creation, thousands of articles, software engineering, financial trading. So, sometimes when you ask for a diagram, it doesn't give you the diagram you think. It might give you a much bigger diagram. But it was really interesting that with one prompt, I can get these kind of diagrams. So when I'm creating, I can also create diagrams that are SVGs that can be edited in code, can be animated. If we have a look at some of the vibe coding tools, I've got my cursor up in the background here, which we can switch over to kind of have some of the look at what it looks like to do vibe coding. Because vibe coding is just agentic behavior on top of things like Visual Studio, and you have an agent code, there are a bunch of open source alternatives, right? So you don't just have to use Cursor. Cursor is the most popular. I think it's just been bought for like $2 billion. So, you know, it's a startup that's now transitioning and being massively valuable. There's also lots of Cursor AI vibe coding tips and techniques as people start experimenting with this way of coding and how you can do things really, really fast. I'm not really going to go through any of those. Certainly, once you start playing with it, you go and look at those code. But my discussion is going to be about talking about those mental models. Right? So, how do I, as a lecturer, deal with my students having lost the tight connection? So it's great if you're a skilled code manager, right? For skilled code managers, because it's not just the sort of programmer thing. You have to kind of step up that one layer up and think of yourself as a manager. I actually turn on, when I'm doing vibe coding and also when I'm doing AI coding, for all of you lecturers, I turn on the bit of my brain that writes first year assignments, and I try and think of it as, how would I unambiguously describe what I want to a first year student who is an A student, right? And so that's how I use the AI, and that's how I think of it. And that actually generally gives me quite good results. Right? For the students, I have to say, right, if you're going to use AI and it will make things easier and faster and remove your time, those are the things you're not going to learn. So I actually work with my students and say, right, what do you want to learn? Because for everything else, you can use AI to do all the rest of the coding, but you don't use it for the things you want to actually learn yourself. Right? So we have to learn how to motivate our students to put in effort and time on those things they want to learn, while also allowing the AI to race ahead, right? And fill up all of the non-interesting tasks. So I'm in the middle, and I'm really interested in feedback. This is where I start moving into asking you guys to chat, and I show you my vibe coding. A concept of navigator coding, where rather than just sitting in the back of a bus and letting the AI drive me to my solution, right? What I do is like with band, I would sit down and I would pick each song that's going to be played tonight, and I'd look at the order in which they're going to happen, and I'd be thinking about, how do I shape this code into what I want it to be, right? And this kind of tries to take vibe coding and add restrictions that allow me as a developer to spend time with my brain bending it into the coding solution space, right? And we have to actively say, this is not the fastest way to solve the problem, right? Like, spending time shaping my brain doesn't help the computer get better at solving the problem. It helps me feel ownership of my code. It's about the developer expanding my brain, expanding my understanding, feeling like, okay, if we want to change this code, I know where we need to go and change it. Now, in something like Cursor, there's these things called system instructions, and that's how you actually force it to, every time you interact with it, you can create the system instructions, which will sit there in the background saying, you know, prefer functional coding over imperative coding, reuse existing functions, always give me 2 to 5 options, so that when you're coding, I don't just turn you full auto and let you run. I am semi-automatic, right? I'm part of the decision making. And so we are moving into this kind of nav programming, and what's coming is what I think of calling as sort of orchestration programming, which is going beyond just me and an AI agent into these model context protocols, the MCPs, which are web servers that provide AIs with tools. So there's an MCP for Git, for example, right? So you set up your own web server with your Git protocols, and you say to the AI, hey, you can use that to do Git things into my repositories. And the AI agents can then go, hey, okay, I can push in some issues into there, and I can do pushes and pulls, and we can start interacting with that as a tool, and the AI has a JSON protocol for the communication back and forth. And so where this is heading over the next 6 months is away from just the vibe coding and potentially away from navigation coding into product owner. I've got a team of AIs. I've got a set of tools that I've orchestrated, that I've brought in, that I've produced, and now I'm managing this whole fleet of AIs, and they're all working together. And my job is to deeply understand the objectives that I'm trying to achieve. How do we, as lecturers, get students from being 18-year-olds to being this able to orchestrate these large networks of communicating AI agents to achieve their goals? So, my advice to lecturers, before we go back into interaction mode, is I do something I call assessment by consent. I have to demonstrate to the students that I care deeply about them, right? So that I care that they are learning. Because if they don't think I care, then why should they care, right? There's a phrase, why if you haven't put in the effort to write it, why should I put in the effort to read it? Right? So if you've just used an AI to write text, why should I, as a lecturer, put in the effort to read it? And I think that goes reciprocal for our students. If you don't care about me as a student learning, why should I care about your opinion as a lecturer? Right? So I think we need to build those reciprocal relationships. We also need to give our students someone to be accountable to. So the idea is that we create a shared goal, and I'm standing at the finish line saying, hey, I'm here, I'm waiting for you. And so it gives them a person, because the internet and the AIs don't care about you, and they don't care if you get to the finish line or not. So that's the new relationship we have. And we have to get the students to think about how they choose the difficult path. They have to choose to put effort and time in. And this is no longer focused on what is the output, because the outputs can now be completely done by the AI. In fact, vibe coding, what I've got over here and what we had before was I have an assignment, and if I find the actual assignment, which is there. So this is assignment 3 for my first year course last year, so this year old, and I was getting them to do a parallax side scroller in processing in first year. I gave them a zip repo, and I talked them through how to submit things, and discussed sprites, and discussed the marking, and then went through the core and completion and extension exercises and funds, and I give them the zip. What I can do for vibe coding is I just take that whole assignment, whack it into the vibe coder, and it implements a pretty good looking side scroller. So if I have a look here, this is so I started I can load older messages. So I started with the older messages, and I just threw in my whole description and let it start coding. And it just sits here talking through, writing code, talking through what it's doing. I can restore checkpoints, but it's got this idea of writing the code. And because I gave it images, it just implemented things. I would occasionally keep iterating until the game is complete. make a to-do with a checklist of the task and update it. And so what that gives me is this to-do list where it looks at the core requirements, the completion requirements, it starts saying the extensions, and it's taken what was that original description, turned it into a checklist, and then started filling those out as it implements them. And the idea here is that by telling it to do a to-do list, that shapes that plan. And it, just sits there coding away, and it generates pretty reasonable files with perfectly good ground level, character height, descriptions, the goal distance, equivalent 50 meters. So yeah, and all of this code, actually perfectly reasonable code, loading the background images. All of this is stuff I can look at and understand as a programmer. It's not doing the sort of that terrible HTML, auto coding HTML where it just becomes bloated, horrific, horrible HTML there is no way you can interact with. I can actually look at this and say, oh, yep, no, all of that makes sense. And if I go to processing and I hit run, it actually is opening on my other window. Yes. As you can see, it hasn't quite got it right, because it's my band of trees isn't the full size of the window, and so this character is now sitting in the wrong position, and it now does things like when I jump, it won't move back right, but it wrote an animation loop, it wrote the parallax to change the things. And so now what I could do is just go into my vibe coding and say running right is not working, and shrink the screen to the size of the background. So, and I can misspell things like running. And now it's just going to sit there and start generating code. It's reading the code from this file, and it's starting to make those edits. And the idea of vibe coding is I just tell it, what I had a problem with. I'm doing it sort of, yes, I've tried to keep telling it to go, so I'm gonna keep hitting accept occasionally, because I've got to tell it to accept, because I've still got it on semi-automatic. So I've made two important changes: running animation and adjusting screen size. So let's go back to our. I really should work out how to force processing to run the window. Haha! Now this is an exciting change, because it's got it wrong enough that it's actually not functional. So size cannot be used here. So it's given me an error. And so what I can do is I can say, I just copy that, whack it in here, and away we go. And say, it's you made it stop working properly. And if I go back to here and go close program, once I've accepted all of those, it just makes those updates, and then I try again. And this is what happens with live coding, is that stuff breaks. So this is the improvement it made. You can see it's shrunk it a wee bit, and still it lets me go right once, but then still it doesn't let me continue right. I'll just close that and press play. So the process here, I can either go in and try and work out why it's done something, or I can just keep yelling at the AI to keep making the window smaller. And I can jump over those obstacles because it made obstacles. And that's interesting. I can jump on top of those platforms. So it's not got the parallax scrolling of the background finished. But I got far enough and I won. So it had win conditions. It coded all this. I wrote no code at all, and it's getting me closer and closer to the goal. How do we convince students that if I give them an assignment and they whack it into their code and it just gets pretty close, that they have to put effort in? So that's the question I have partly for you, is what do we do about our students trying to give them that motivation to care about how their brain changes so that they adjust their thinking to understand what the world looks like as a programmer? Okay, thank you very much, and let's go to questions. If there's still people online.